Welcome to my channel Chemistry Class. Welcome back to Chemistry Class, my dear student. I hope you are doing well. So, in the previous lecture, we discussed about ways to recognize equilibrium, and today we will learn about another very important concept in chemical equilibrium, which is equilibrium constant and its a unit. So let's understand step by step. Now, what is equilibrium constant? My dear student, when a reversible reactions reaches equilibrium, the ratio of the product of concentrations of products raised to their stoichiometric coefficient to the product of concentrations of reactants raised to their stoichiometric coefficient becomes constant at a fixed temperature. This constant ratio is known as the equilibrium constant. Now, definition: the ratio of the product of concentration of products to the product of concentration of reactants, each raised to the power equal to their respective stoichiometric coefficient, is called the equilibrium constant. Now, mathematical expression. Let's consider a general reversible reaction: A moles of A plus B moles of B ga- gaf C mole of C plus D mole of D. My dear student, at equilibrium, the equilibrium constant Kc is written as Kc is equal to concentration of C per C or concentration of D per D divided by concentration of A per A and concentration of B per B. My dear student, where A, B and D are the molar concentrations and moles per decimeter cube of reactants and products at equilibrium, while and small a, b, c, and d are their stoichiometric coefficient. But dear student, also note that the subscript c and Kc indicates that concentrations are expressed in moles per liter, or means mole per decimeter cube. If partial pressures are used instead of concentrations, it is represented as Kp. Now, important point about equilibrium constant in Kc. First one, Kc depends on temperature, mean changing temperature changes the value of Kc. And the second one, Kc is independent of the initial concentration of reactants or products. And third one, Kc has a fixed value for a particular reaction at a given temperature. And the fourth one, Kc helps to predict the extent to which a reaction proceeds. Examples: the first one, consider the reaction between hydrogen and iodine to form hydrogen iodide. H2 gas plus I2 gas gave 2Hi is also a gas. The equilibrium constant Kc for this reaction is written as Kc is equal to concentration of Hi per 2 divided by concentration of H2 and concentration of I2. Now, dear student, this means that at equilibrium, the ratio of the square of Hi concentration to the product of H2 and I2 concentrations remains constant at a fixed temperature. And the second example is for the formation of ammonia, N2 is a gas plus 3H2 is also a gas, Gaf2H3 is also a gas. The equilibrium constant is given as Kc is equal to concentration of H3 per 2 divided by concentration of N2 and concentration of H2 per 3. Now, units of equilibrium constant mean Kc. Dear student, the unit of Kc depends on the number of moles of reactants and product involved in the balanced chemical equation. Let's draw at in generals. For the general reaction, A moles of A plus B mole of B, of C mole of C plus D mole of D. The expression for Kc is equal to concentration of C per C, concentration of D per D divided by concentration of A per A, concentration of B per B. My dear student, each concentration as in moles per decimeter cube. So the unit of Kc is equal to mole per decimeter cube power C plus D minus A minus B. Hence, Fc plus D minus A minus B is equal to 0. And Kc has no unit. It is dimensionless. Fc plus D minus A minus B does not equal to 0. And Kc has units depending on that value. Now, examples of unit reaction Kc expression calculation of C plus D minus A minus B unit of Kc. Now, reaction H2 is a gas plus I2 is also gas, Kf2 Hi is also gas. Kc expression is Hi, concentration of Hi per 2 divided by concentration of H2, concentration of I2. Now, calculation of C plus D minus A minus B as 2 minus 2 is equal to 0. So Kc has no unit. Second reaction, N2 is a gas plus 3, 2 is also gas, F2 NH3 is also gas. Now concentration of NH3 per 2 divided by concentration of N2, concentration of H2 per 3. Calculation of C plus D minus A minus B as 2 minus 4 is equal to minus 2. And unit of Kc is mole per decimeter cube per minus 2 is equal to decimeter cube per moles and whole power 2. And third reaction, 2SO2 is a gas plus O2 is also gas, Gaf2SO3 is also gas. And Kc expression is concentration of SO3 per 2 divided by concentration of SO2 per 2 and concentration of O2. And calculation of C plus D minus A minus B as 2 minus 3 which is equal to minus 1. So unit of Kc as decimeter cube per moles. Now, significance of equilibrium constant in Kc. First one as indicates the extent of reaction. When a student Fkc is large, reaction favors products when equilibrium lies to the right. Fkc is small, reaction favors reactants when equilibrium lies to left. Second one helps in predicting the direction of reaction and calculating unknown concentration at equilibrium. And third one, used in industrial processes such as Haber process, contact process, RDC to optimize yield. So, my dear student, this is all about today's lecture on equilibrium constant and at CNET. I hope you understand. So, if this lecture will help you, then don't forget to like the video, subscribe to the channel for more chemistry lecture, and share it with your friends. Comments your question below. Take care and see you in the next class, inshallah. Thank you for listening.